Let's talk about inverse variation. Our working equation for inverse variation is y equals k over x, where k is the constant of variation. Now notice this is different from our direct variation equation. With direct variation, we said y is equal to k times x, but now with inverse variation, we are dividing by x. Let's take a look at how this will work with a problem for inverse variation. Here is our problem. If y varies inversely with x and y is equal to 33 when x is 3, find x when y is 15. First, let's find our constant of variation, k. Here is our working equation, y is equal to k over x. We are told that y is 33. So let's begin by putting 33 in for y. We're also told that when y is 33, x is going to be 3. So let's put 3 in the place of x. Now, if we solve this for k, multiplying both sides by 3 to eliminate the fraction, we'll find that k, our constant of variation, is 99. Now that we know that k is 99, we can look at the new situation where our y is changing to be 15. Let's again set up our working equation. Y is equal to k over x, but now this time we're going to use a y that is 15. Here is where we've substituted it, and we found that our constant of variation, k, is 99. So now, if we multiply both sides by x to get rid of the fraction, we'll have 15x equals 99. To solve this, we need to just divide both sides by 15. Dividing 99 by 15 gives me 99 over 15, which reduces to 33 over 5. So when y is 15, if it varies inversely, then x will be 33 over 5 for this problem. Now, frequently we'll have word problems that involve inverse variation. Let's look at an example of that. The current in an electrical circuit is inversely proportional to the resistance. If the current is 80 amps when the resistance is 50 ohms, find the current when the resistance is 40 ohms. Well, our working equation is y equals k over x. Notice that it says that the current is inversely proportional to the resistance that we have. So current is inversely proportional to resistant, and k is a constant of resistance. Now, let's substitute the things that we've been told. 80 amps, that's our current, goes in for C. 50 ohms, that's our resistance, that goes in for R. If we solve this, multiplying both sides by 50, we find that our constant of variation is 4,000. Now, if we know that the constant of variation is 4,000, we can find the new current with 40 ohms being the resistance. The current is equal to our constant of variation divided by the resistance that we have, which was 40. 4,000 divided by 40 gives us 100 amps for the current. Notice that changing the variables to make sense with the problem makes this one a little bit easier. Instead of leaving it in our working equation, y equals k over x, we changed it to be the current is equal to our constant of variation over our resistance. Now, this is easier for us to substitute into. How we know how to set this equation up, it tells us the current, that's C, that's our equals, and inversely proportional means we need the fraction with the resistance. So K over R. Let's look at a final example. The intensity of light produced by a light source varies inversely as the square of the distance from the source. If the intensity of the light produced 3 feet from a light source is 750 foot candles, find the intensity of light produced from the same source at a distance of 5 feet. Well, we like to start with y equals k over x. This time, we know that the intensity is varying inversely. So intensity is our constant of variation over our distance squared. The square of the distance, that is our denominator. Now, we were told 750 foot candles is the intensity when we have a distance of 3 feet. So let's put 750 in for intensity. Our distance d was 3, so if we take 3 and square it, that will give me 9. Now, I want to solve this for k to find our constant of variation. When we multiply both sides by 9, looks like k is 6,750. If we know that k is 6,750, we can work our new situation. Putting 6,750 in the place of k, we were told use a distance of 5 feet. So let's put 5 feet in for the distance. The distance is being squared. Now, 5 squared is 25. So if we take 6,750 and we divide by 25, that gives us an intensity of 270 foot candles. The intensity when we are 5 feet away is 270 foot candles. Notice that this number is less than the 750 that we started with. It makes sense that the closer we are to our light source, 3 feet away, the more intense our light would be, 750 foot candles at a distance of 3 feet, while it was a lower number at a distance of 5 feet. The further you are from the light source, the darker it's going to get. So the key words here, varies inversely, told us to use y equals k over x. When we substitute into our working equation the intensity and the distance, then we can find the resulting foot candle intensity at any distance that we want.